Hi guys, welcome to today's tutorial looking at the unit circle, possibly one of the more complex ideas to get your head around. I suggest have a look at my unit circle one with the obtuse angles within trigonometry. That looked at the first two quadrants. I'm going to be looking at all four quadrants this morning, and I suggest also look at other videos on YouTube and have a look at some of the lessons there, because I'm sure I won't cover it all, but I'm going to do my best. Okay, so far we've looked at angles within that first quadrant, well, most angles within that first quadrant. Okay, so what I'm going to do is just draw a nice little angle in my first quadrant. Now, a unit circle is a circle with radius of 1 unit, as you can see, which then gives me a hypotenuse of this triangle of 1 unit also. If I call this the point xy, which means I've gone across x units, and I've gone up y units. So I'm going to look at my trig ratios of sine, cos, and tan. Cos theta and tan theta within this particular triangle. Now, these are all going to be acute angles. Okay, so they're my first quadrant, and they're all going to be acute angles because they're all less than that 90-degree angle, as you can see there. So my sine theta, well, that will obviously equal y over 1, and y over 1 is simply just y. Cos theta is adjacent over hypotenuse, so x over 1, or just x. And tan theta is y over x. Okay, and I can't really simplify that any further. One thing I do want to know, I'm just going to mention this now because I'll be mentioning it later on anyway. Tan theta, as you can see there, is equal to y over x. Now, y we know is the same as sine theta, and cos theta is the same as x. So actually, an identity that you will learn later on will be tan theta equals sine theta over cos theta. Likewise, we know that cot theta is the inverse of tan theta, which will mean that it is cos theta over sine theta. Okay, just a couple of trig identities that you'll need to know a little bit later on. Not so much today's lesson, but a little bit later on. Okay, so we've looked at here all these angles within that first quadrant. Now, let's say I want to look at angles that are obtuse angles. Okay, now these will obviously come into the second quadrant because they need to be bigger than that 90-degree angle. So what we're going to do is I'm going to draw another triangle here. Now, obviously, what I'm looking for is that amount there. I mean, let's ignore this stuff here. Okay, I can't really, unfortunately, rub that out. I'll try to rub that as much as possible. Okay, so I'm trying to look at that angle there because that's my obtuse angle. So a good way to look at it is this. If I put theta in there, then this angle here is going to be 180 degrees minus theta. Yep, okay, because a straight line's 180 degrees, and I'm going to subtract theta, I'm left with the angle. So if I look at this and say sine 180 minus theta, okay, so 180 minus this angle here. So I need to figure out what this angle is going to be. So we've gone across x. Now we've gone to the left of 0, so that's going to be minus x, and I've gone up y. So let's have a look at sine theta to start off with. Well, sine theta is opposite over hypotenuse, which is y over 1, which is just y. Cos 180 minus theta, so again, I've got 180 degrees, and then I'm minusing the theta, is equal to adjacent, which is minus x over 1, which is just minus x. And tan theta, or tan 180 minus theta, tan is y over minus x. So what we've actually worked out, that sine 180 minus theta is actually the same as sine theta. They both have the same values. That cos 180 minus theta is equal to negative x, so negative cos theta. And y over tan 180 minus is equal to negative tan theta. So in my second quadrant, we've worked out that if I just find out the value of theta, okay, so if I'm looking for, let's say, 140 degrees, let's find sine 40 degrees, but I know it's going to be a positive if in the second quadrant because it's sine. Now this is called, we notice that all these signs here were positive, so everything was positive, all. In my second quadrant, we've just realized that sine is positive. These are going to be important a little bit later on. I'm going to do the same thing for the third quadrant. Okay, so third quadrant, I'm going to drop my line, my radius up there. Dot, 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 dot. Okay, so if I want to find out the whole way around, that's the same as saying, I guess, we're going to find, put here third quadrant, sine 180 degrees plus theta. Yep, because I've got 180 degrees, I'm just going to add that theta there. So if I can find that angle there, then I have to add 180 degrees, we can find it out. So we know we've gone across minus x, we've gone down this time minus y. So let's have a look what the value is going to be for sine. Okay, so sine is opposite, which is minus y over hypotenuse of 1, which is just minus y. Cos 180 degrees plus theta, because then that gets my reflex angle. Okay, well, adjacent over hypotenuse, which is minus x, and if I'm trying to find tan 180 plus theta, okay, we've got opposite minus y over minus x, so minus y over minus x is simply just y over x. Now again, if we look up here, sine 180 plus theta is the same as minus sine theta. Cos is the same as minus cos theta. And tan is just the same as tan theta. So if you have a look here, all the same values again. If I'm looking for, let's say, sine 200, that's the same as just finding the negative of sine 20. Okay, which we can do. So everything's negative apart from tan. Tan's the only positive one there. Okay, and let's have a look up to the very last one. This will now be in our fourth quadrant. So look, we're looking for angles above 270. Okay, above 270, or let's say 360 minus. That might be better. So if we do sine 360 minus theta. So if I'm looking for, let's say, sine 330. Okay, that's the same as saying 360 minus the 30-degree angle. So what we're going to do, we're going to drop a line there, just like we did there, and say if I can find out whatever theta is, okay, from this triangle, all I do have to do is take away from 360 degrees, and I've got that angle there. Okay, so this case, it's gone across positive x, like we had at the beginning there, and then we've gone down minus y this time, and my radius is still 1. So let's have a look. If I find 360 minus theta, we've got, let's have a look. So sine is minus y over 1, which is just minus y. Cos 360 degrees minus theta. Okay, so again, I go 360 and then I take it away. Is adjacent, so it's x over 1, which is just x. And then cos, tan 360 minus theta is equal to opposite, which is minus y over x, which is minus y over x. And then we can see there, so sine 360 minus theta is the same as minus y, so minus sine theta. Cos 360 minus theta is exactly the same as x, so it's the same as cos theta. And then that's the same as negative tan theta. Okay, and you can see there, like the other ones, we've got one of them is positive, which is cos. Okay, so we've got all these different angles. So, I mean, how is this going to help me? And we'll go back through this ASTC in a moment, because that's quite important. But let's say, I mean, what does all this give me? Let's say, for example, I'm trying to find the value of tan 330 degrees. Well, we know that is the same as saying 306 tan 360 minus how much? Minus 30. Okay, so and that, which is the same as, so if I can find out what tan 30 is, then I just need to take it away. But we know from here that tan 360 minus that is the same as simply saying minus tan 30. So if I can find out what minus tan 30 is, that's going to be the same value. Well, it's going to be negative, and tan 30, we know, looking for my 60-30 triangle, which is 1, 2, root 3, tan 30 is opposite over adjacent, which is 1 over root 3. So tan 330 is the same as negative tan 30, which is that value there. So you can see the benefit of knowing what they are. Now, what is this ASTC business? ASTC is very important because I know if I've got an acute angle, so less than 90, then every single one of these things is going to be positive. Okay? Sine in the second quadrant, so if I have an acute angle, sine will be positive, but the other two values will be negative. Tan in the third quadrant will be the only positive value, the rest will be negative, and cos, as you saw here, is the only positive value. So because I know that tan is negative in that fourth quadrant, I knew my value is negative 1 over root 3. Okay, hopefully that's made a little bit of sense. Now let's start looking at some questions that it will be more applied to and sort of make things a little bit easier. So what will some questions look like? Okay, well, easy questions will be things simply like this. Find the exact value, which we were doing last lesson, the exact value of sine 225. Now, I know looking back at our, our triangles, so we drew our two triangles for our exact values. So if I do that, we've got 60, 30, so that's 1, 2, root 3. And then this one is my 45 degree right angle isosceles triangle. So 1, 1, root 2. I don't have a 225 degree angle there. But from that unit circle that we looked back here, we know that 225 degrees is the same as doing 180 plus 45 degrees. Okay, plus 45 degrees. So sine 225 is the same as doing sine 180 plus 45 degrees, which we were also told was exactly the same as finding sine theta, which is sine 45, but in that third quadrant, because it's 225 degrees, all stations to central, that tan was positive and the other two signs were negative. So if I can find out what sine 45 is, then I know it's a negative whatever that value is. So sine 45 is 1 over root 2. We know that sine is negative in that third quadrant, so my exact value is simply negative 1 over root 2. Okay? So that's the benefit of this stuff. Let's have a look at another question. Let's say find the exact value, and you might want to pause this and have a crack at this yourself, of cos 390 degrees. Now this is slightly more challenging. This is why I'm showing this one actually. If I draw my unit circle there, you might think, okay, how can I do this? Because if I go 360 degrees all the way around, I get back to there. But I've still got 30 degrees to go. So you keep going. Just keep going an extra 30 degrees. So you're going 360 once, and I'm just going an extra 30. So cos 390 is the same as saying cos 360 add my 30 degrees. We already know it's in that first quadrant, so we already know that my cos 390 is going to be a positive value. So all I need to figure out is what cos 30 is going to be. Okay, so hopefully draw my triangle again, 60, 30 triangle. We have 1, 2, root 3. So cos 30, you can see, is root 3 over 2. And we know in the first quadrant it's positive. Got my answer. All right. They're not all as easy as that. There's one question which I haven't shown you, which I probably should have spoken about. And I said before that sometimes I do miss things. Okay, or I probably will miss a couple of things. But you might find a question like this. Find the exact value of tan negative 150 degrees. Now this is really important. Okay, let's draw my unit circle. I know it's not the best unit circle. Okay,